days, viewers. You are welcome to physics class. And today, we shall be looking at a topic titled Transmission of Heat. As we all know, that we have so many instructional charts and posters that we can use to achieve the teaching and learning of this topic. But today, for the purpose of this class, we shall be looking at the chart and posters showing conductivity of liquid. Then followed by another chart showing the different way of comparing conductivities of metals. But the last and not the least of all the charts we have for this class is a chart showing the compound bar. Happy viewing. Thank you.
You are welcome into physics lesson. The topic before us today is transmission of heat. What do I call it? Transmission of heat. The objective of this lesson is that at the end of this lesson, you should be able to define transmission of heat. And you should be able to state the three types of heat transfer. And you'll be able to identify the good and the bad conductors of heat. You should be able to compare the conductivity of metals and liquid as well. You should also be able to explain conventional current. You should be able to explain land and sea breezes. All these you should be able to explain at the end of the lesson. Now, what is transmission of heat? Transmission of heat is exchange of thermal energy between a physical system. What I'm saying here is that there is the heat moves from one point to another depending on the kind of material we use. There are three methods through which heat can move. The three methods are: 1. Conduction, 2. Convection, 3. Radiation. Let us look at conduction. Conduction is a process of heat transfer through solid materials. It is a process of heat transfer through solid materials. Such solid materials are metals. Generally, are good conductor of heat. And examples of metals are iron, copper, brass. All these are examples of metals. And like I told you, that generally all metals conduct heat. But different metals conduct heat at different rates, depending on the type of metals we have. And this will lead us to what is called conductivity of different metals. Different metals are arranged inside a container connected to an electrical source. Different metals of the same length. Different metals of the same length are arranged inside a container connected to electrical source. And on each of these metals, a candle wax is wound round at the other end of it. Immediately the switch is on. Heat is connected, it's generated through the metals. We find out that the candle wax melt gradually, depending on the conductivity of these metals. In conclusion, we see that the candle wax on copper melt first. The candle wax on copper melt first. That is to tell you that on the top of copper, you will not see as much as you see on wood, followed by aluminium, followed by iron, followed by brass, then followed by glass, and lastly by wood. You can see on wood, the candle will remain the same. That is to tell you that wood is a bad conductor of heat, but copper is a good conductor of heat. But naturally, we want to go into the conductivity in liquid. We find out that water is a good example of liquid, and water is a bad conductor. How do we experiment this? What we do is, let's put some water inside a test tube, as shown on the board, and a nice block is placed at the bottom of the water inside the test tube. The test tube is heated on the top. We find out after some time that the water on the top of the test tube is boiling, while the ice block remains unmet. The ice block remains unmet, showing that water is a bad conductor of heat. The second method of heat transfer is convection. Convection is the process of heat transfer through which the material, the molecule of the materials are moving. The molecule of the material are moving. For instance, water is a very good example. If you boil water, you find out that water is boiling. The molecules at the bottom will rise from the bottom to the surface, and the one at the surface will return to the bottom. This will lead to what we call convection current. Convection current. The convection current is if we put a round bottom flask and we put a crystal of a potassium permanganate at the bottom of the flask. If the crystal of the permanganate is heated at the bottom, we find out that the color of the permanganate is still moving around, as shown in the diagram. It will be moving around. As it's moving, other ones from the top will replace it. This circulation is called convectional current. The circulation is called convectional current. Good. The uses of this convectional current can be useful in some areas. It is useful in some areas. For instance, domestic boiler. The domestic boiler is a hot water circulation system used in domestic supplies. Many of you have in your bedroom, you have that big bath in your bedroom where you have cold water and hot water. This is a good example of domestic boiler. How it operates is this. The hub here is the reservoir for cold water. While the down here is the boiler. If the water here is the reservoir for hot water. As the cold water is moving through this harrow into the boiler boils it. When it boils it, it goes back into the reservoir, hot water reservoir. And the hot water reservoir now move. It will move to the tap here, where the hot water will be coming out of the tap. And the other one, this one, as the cold water is moving, the hot water is lighter. It's lighter than the cold water. So it moves up. And the cold water from the reservoir here comes in to replace it. It will continue that circulation until the hot water is boiled. And here the cold water moves to the tap here. So if you need cold water in your room, or in your toilet, or in your bedroom, you open cold water, and if you need hot water, you open hot water. Are you following me? So these are the system we call domestic boiler. Good. The third method of heat transfer is radiation. Radiation is a process whereby it is transferred. Radiation is a process whereby it is transferred through an empty space. Unlike conduction and convection, where material medium is necessary. In radiation, there is no material medium. It is through electromagnetic waves. It comes in straight. Like many of you, when you walk in the sun, you find out that you feel the hotness hotness of the sun, and there's nothing in the intermediary. So it is a process whereby heat is generated through an empty space without hitting the intervening medium. Good. See example. This is an example of a material used to demonstrate radiation. We call this Leslie cube. This Leslie cube is a cube containing hot water, but all the sides are painted with different colors. One side is painted with black, other side is painted with different color, but not black. So we rotate each of the side to what is called a thermopile. A thermopile is a device used to measure radiation. So each of these sides will face thermopile. Depending on the color of the side will determine the derivation of what? Of the thermopile. So if the black, you notice that the black surface, when the black surface faces the thermopile deflection will be larger, indicating that black surface is a good emitter of heat. Good. So it shows black surface is a good emitter of heat, and so that a good absorber of heat. Another good example is emission in this diagram. This diagram contains two narrow tubes of the same length. Two narrow tubes of the same length. The pop on the top here is painted black, while this one is painted shiny color. Now, inside this tube, there are what we call oil. In the oil, the heat is generated, this is heat source connected to heat material. Supply heat into this place. This side that is painted black will generate heat first. And we find out that the heat will heat the oil. When the oil is heated, it becomes lighter and it moves down and pushes this one up. So that is to tell you that the black body is a good absorbent of heat. Another good example is this. These are two rods of the same length. A cork is attached to the sides of the rod with the head of a candle wax. The rod here is painted black. This other one is a shining color. And there's a Bunsen burner at the center, equal distance from the two rods. As the heat is generated, we find out that the cork attached to the black body drop first. Why? Because the candle wax has met, and the one on the shining surface remaining unmet. That's to tell you that a black body is a good absorbent of heat. Is that okay? So all these are the explanation of radiation, convection, and conduction. We are three different types of heat transfer. Students, I believe with all the explanation, you should be able within you to stage examples on your own of convection, conduction, and radiation. Is that okay? Thank you very much. God bless you. Any question, please? No question. It's understood? Thank you.